In Chapter 7, we're going to be doing a whole bunch of hypothesis testing. So we've kind of graduated from learning all the components about statistics, about how to do confidence intervals, and now we're actually going to do hypothesis tests. So 7.1 is an introduction to that hypothesis testing. So it's a whole bunch of terms and processes. And then once we get into 7.2 through 7.5, we'll do specific types of testing. So we're going to start with what is a hypothesis test. And it's just something that you use to test a claim. So that's what it's all about, is testing a claim, whether a claim is valid or not. Okay, like for example, you are supposed to consider whether a manufacturer that advertises its new hybrid car has a mean gas mileage of 50 miles per gallon. So the manufacturer wants to advertise that it gets 50 miles per gallon because that is a good feature of a car for a consumer, but is it actually true or not? That's what a hypothesis test does, is it tests whether or not something could likely be true. Okay, so this is the claim by the manufacturer. Okay, so in statistics, a hypothesis is a statement about a particular population parameter. In this case, it was that the mean is equal to 50 miles per gallon. That would be the parameter that we're talking about. When you are doing a statistical hypothesis test, you need to state two pairs or one pair of hypotheses. One that represents the claim and the other one is its complement. Okay, and those claims are the null hypothesis and the alternate hypothesis. Okay, since one is the claim and one is the complement, there can only be one or the other is true. They cannot both be true at the same time. So the null hypothesis is written like this. So H sub 0, that's null hypothesis. And the way they say that is H naught. And the alternate hypothesis is written as capital H with a little subscript A, and that means H alternative. That's what the A stands for. The null hypothesis, H naught, is a statement that contains either a less than or equal to, an equal to, or a greater than or equal to. The alternate hypothesis, H sub A, would be the complements to those with less than, greater than, or not equal to. Okay, so our null hypothesis for our previous example could be, so their claim is that their car gets 50 miles per gallon. Now, that doesn't mean that it gets 50 miles per gallon or less. They want to claim that it gets at least 50 miles per gallon. So the claim is usually placed in the alternate hypothesis statement, because the whole purpose of doing a hypothesis test is to show that your product is unusual in that there's something special about it that makes it marketable in that way. So our H alternate hypothesis is that the mean gas mileage is greater than or equal to 50 miles per gallon. That is the claim by the manufacturer. Where the H naught, the normal for all cars from all manufacturers, is that the mean gas mileage would be less than 50 miles per gallon. This is what the manufacturer wants to prove false for their car. They want to have this happen so that they can say that theirs is unusual. Remember, the alternate hypothesis is always the complement of the null hypothesis. So since the mean is greater than or equal to 50 here, the complement would be the mean is less than 50. So these are examples of how you can write your null and alternate hypothesis statement. K is some number that represents that parameter. So these are just examples. So let's practice writing some of these. Write each claim as a mathematical sentence, state the null and alternative hypothesis, and identify which represents the claim. Okay? A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So they must be promoting that 61% of their students are involved in extracurricular activities. Okay, so in this one, the null hypothesis is that the proportion of students is equal to 61% or 0.61. So out of all of the possibilities at 61%, this represents the claim. That means that the alternate hypothesis would be that it wouldn't be 61, or that the proportion is not equal to 0.61. That means that everything from here on out, or everything from here on up, would be the alternate hypothesis. And only this point would be the null hypothesis. In this next one, a car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, so the null hypothesis and the alternate hypothesis. So they're claiming that their oil change time is unusual in that they can do it in less than 15 minutes. So that means the mean is less than 15 minutes is what they are claiming. So when we do a hypothesis test, we'll be able to say that, no, we're rejecting the usual. We're saying that our claim is unusual, and we're going to reject the null hypothesis. So that means that the null hypothesis is everything else that's not included in the mu is less than 15. So that means the mu would have to be greater than or equal to 15 minutes. So on a number line, at 15, we would have that the claim is everything less than 15 minutes. That's our alternate hypothesis. And from 15 on up, so 15 minutes or more, would be our null hypothesis. And this last one, A company advertises that the mean life of its furnaces is more than 18 years. So you want your furnace to last as long as possible. So they're saying that theirs is going to be 18 years, more than 18 years. So once again, our alternate hypothesis is going to be that the mean is more than 18 years. So everything above 18. And the null hypothesis then, the thing that we would prove to be false, or hopefully prove to be false, would be the opposite of the mu is greater than 18, which is the mu is less than or equal to 18 years, meaning that the furnaces from the other companies are inferior or don't last more than 18 years. So that's going to be from 18 below. So this would be the null hypothesis, and this would be the alternate hypothesis.